Isomerism in coordination compounds. Two or more different compounds having the same formula are called isomers. Two principal types of isomerism are stereoisomerism and structural isomerism. Stereoisomers contain the same number and kinds of atoms, but the atoms are arranged differently in space. There are two types of stereoisomers: geometric isomers and optical isomers. Structural isomers contain the same number and kinds of atoms, but one or more bonds are different. Stereoisomerism. It is of two types: A. Geometrical isomerism. B. Optical isomerism. Geometrical isomerism. Metal complexes that differ only in which ligands are adjacent to one another, cis, or directly across from one another, trans, in the coordination sphere of the metal are called geometrical isomers. They are most important for square, planar, and octahedral complexes. In a square planar complex of formula mx2L2, X and L are unidentate. The two ligands X may be arranged adjacent to each other in a cis isomer or opposite to each other in a trans isomer. In octahedral complexes of formula mx2L4, in which the two ligands X may be oriented cis or trans to each other. Optical isomerism. Optical isomers are related as non-superimposable mirror images and differ in the direction with which they rotate plane polarized light. These isomers are called as enantiomers of each other. These two forms are called dextro D and levo L. D rotates to the right, L to the left. Optical isomers are possible for both tetrahedral and octahedral complexes, but not for square planar. Structural isomerism. It is divided into four types: 1. Linkage isomerism. 2. Coordination isomerism. 3. Ionization isomerism. 4. Solvate isomerism. Linkage isomerism. Linkage isomerism occurs in a coordination compound having ambidentate ligand. For example, complexes containing the thiocyanate ligand NCS-, which may bind through the nitrogen to give MNCS or through sulfur to give MSCN. Coordination isomerism. In a coordination isomer, the total ratio of ligand to metal remains the same, but the ligands attached to a specific metal ion change. In CONH3 CrCN6, the NH3 ligands are bound to CO3+, and the Cn- ligands to Cr3+. In its coordination isomer, CrNH3 COCN6, the NH3 ligands are bound to Cr3+, and the Cn- ligands to CO3+. Ionization isomerism. Isomers that result from the interchange of ions inside and outside the coordination sphere. Examples are COBr H2O5 plus Cl minus and COCl H2O5 plus Br minus, CO NH3 5SO4 Br and CO NH3 5 Br SO4. Solvate isomerism. This form of isomerism is known as hydrate isomerism. Hydrate isomers are isomers of a complex that differ in placement of the water molecules in the complex. Examples are CrH2O6, Cl3 violet and its solvate isomers CrH2O5, Cl, Cl2, H2O, gray-green and CrH2O4, Cl2, Cl2H2O, dark green.